Alright, so today we come to one of my all-time favourite lessons. It's drawing in 3D. A lot of the trigonometry questions that you might get in a modelling and problem-solving question involve 3 dimensions. You're going to really struggle with that if you can't visualise it in some way, if you can't draw it in some way. So I'm going to give you a quick method. You guys might have other ones, but this is the one that I use. Now normally you would do something in 2 dimensions at least when we talk about bearings. You'd have north, east, south and west like that. Now that's not going to work because you need to also accommodate an up and down. So what we're going to do instead is the following. Now east and west will still be the same. But when you put your north and south in, put your north and south at a 45-degree angle. There's north and there's south. Now the reason we do that is because that now accommodates our 3rd dimension, up and down. Now, once we've sort of got our head wrapped around this, it becomes much easier to start drawing our diagrams. The way that I like to draw my diagrams is start by creating what I like to call my action box. It's a box where all of the action, where all of the drawing can take place. Draw a box like this. Now it should look something like that. Now I like to put dotted lines in here because they're the parts of my box that I can't see. Oops, missed a line. There we go. Now we have our action box here that allows us to think about things in 3 dimensions. Now a pretty classic question is the flagpole question. So if we put a flagpole in here, it starts in the middle of my action area and the flagpole goes up. There's my flagpole. Now you can see it's gone up, okay? In a 2-dimensional drawing that would be north obviously. Now if someone was standing to the east of that, we know that he's standing over here. So there's my person standing to the east of that flagpole. Now if someone's standing to the south of that flagpole, don't draw straight down like that. That's not south, that's down. That means they're going underground. You don't want that. Now if someone's standing south of that flagpole, 45-degree angle. And there's my person standing south of that flagpole. Now we can start doing really fun sort of trigonometry stuff here. Maybe there's a rope going from here down to this guy. Maybe there's a rope going from here down to this guy. Just to make things really complicated, there might also be a guy somewhere else. Let's say there was a guy at north 30 degrees east. Now if a guy was at north 30 degrees east, this is north here, so he would be north 30 degrees east, so move 30 degrees. Now that's a 45-degree angle there, so when you move 30 degrees, really you're only moving just a little bit. So there's my 3rd person at north 30 degrees east. That means that that angle is 30 degrees. And again, maybe he's holding a rope as well. A whole bunch of angles start happening here. You can start working with a lot of different stuff. If you follow that way of drawing, you shouldn't have too much trouble with at least representing modelling and problem solving questions in 3 dimensions.